Okay, today we're going to take a look at reasoning with properties from algebra, and this first slide is going to give you a lot of the properties that you've already known from the time that you were little. For example, if A equals B, then A plus C equals B plus C. If A equals B, then A minus C equals B minus C. In other words, what you do to one side of an equation, you do to the other. So if you add to one side, you have to add to the other. If you subtract from one side, you subtract from the other. If you multiply from one side and divide from one side, you have to do it to the other, and so on and so forth. Okay, where a couple of properties are going to change this a little bit. I mean, if the reflexive property. For any real number, A equals A. And when we look at the reflexive property, one of the things that you want to make sure of is you recognize that you look at how many things are actually being compared. Okay, so we look at the reflexive property. The reflexive property actually has one thing that's being compared. A equals A. Okay, that's going to be a little bit different as we look at some of the other ones. The symmetric property says if A equals B, then B equals A. All this does is allows you to switch your order. Okay, it switches the order. Okay, if A equals B, then B equals A. Just flip both sides of my equation. And a transitive property says if A equals B and B equals C, then you can put A equals C together. Okay, it's like the law of syllogism. Okay, so the transitive property, law of syllogism are the same. And lastly, the substitution property says if A equals B, then A can be substituted for B in any equation or expression. And you're going to see that happen a little bit later on, but you're going to need to recognize that the transitive property and the substitution property are going to look a lot the same. Okay, with the reflexive property, A equals A, there's one thing being compared. If you look at the symmetric property, there's two things being compared, A and B. Okay, so B equals A. And finally, the transitive property, if A equals B and B equals C, then A equals C. And there's three things being compared in the transitive property, which starts with a T. Remember, the symmetric property is a switch. And the reflexive property says everything is equal to itself. Okay, just like you were looking at a reflection in a mirror. Okay, so reflexive property is one thing being compared. Symmetric property, two things are compared. With the transitive property, there are three things that are compared. So what we're going to be looking at mostly tonight on the homework is going to be identifying the properties, and we're going to tie those together a little bit more. Okay, if we take a look here on number 1, QR is congruent to QR. So how many things are equal there? Okay, there's 1. So since there's one thing that's being compared, okay, that is the reflexive property. Okay. Letter B. How many things do we have being compared here in letter B? Okay, you have an H, a J, and an N. Okay, so there are three things that are being compared. And since there's three things that are being compared, that is a transitive property. And finally, if WX equals YZ, then YZ equals WX. Okay, so how many things are being compared? You have 1, 2. Okay, and since there's two things that are being compared, this is the symmetric property. Okay, the symmetric property is switching my order. Okay, Y, Z, and WX are being switched. Okay, get the property that justifies each statement. Okay, if the measure of angle 1 equals the measure of angle 2, then the measure of angle 2 equals the measure of angle 1. Okay, how many things are being compared? Okay, there are two things that are compared. So that is which property? Symmetric. Okay, it's like a symmetry line. Okay, you're just flipping it around. Okay, number 2, the measure of angle 2 equals the measure of angle 2. Okay, how many things are being compared? Okay, there's one thing. So that tells you you're looking at the reflexive property. Okay, moving on. Okay, if EF equals GH and GH equals IJ, then EF equals IJ, how many things are compared here? Okay, EF, GH, and IJ. So that's three things. That's transitive property. finally, number 4, if EF equals 8 and EF equals GH, then GH equals 8. The fact that you have a number in here changes this a little bit from the transitive property. Well, there are 3 things that are compared up here. Because you have a number, you want to use the word substitution. Okay, because I am substituting 8 in for EF. Okay, so you want to use substitution there now. And that's really going to be a lot of the focus of the homework tonight. Okay, there'll be a couple other things that are going to happen. Okay, we want to use the property to complete each statement. Okay, the multiplication property of equality says if x equals y, then ax has to equal. And what we're looking for here is just the difference between these two pieces. Okay, from x to ax, here's multiplying by both sides by a, so you get ay. Okay, the symmetric property, if fg equals hj, remember we're going to switch your order, because the symmetric property is a switch. So hj equals fg. And then finally, the transitive property says if bc equals kl and kl equals yz, then what? Okay, so what you're really kind of looking at here is just like this law of syllogism we talked about yesterday. The KLs are going to disappear because they show up in both of our equality statements, and BC is going to equal YZ. Okay, we're going to solve our equation and state a reason for each step. Okay, so my equation is 3m minus 2 equals m plus 8. Now, when we work through these equations, what we're going to do is justify what we did to get from one step to the next. And we're going to follow through just like we do with normal equations. So when I work through an equation, I'm going to take my smaller m to my bigger m. So what I'm going to do is I'm going to subtract that. So when I subtract m from 3m, I'm going to get 2m minus 2 equals 8. And what I did was subtracted m from both sides, so I'm going to list that property as subtraction. Now, when you've worked through these equations as you've gone through the class, you've constantly had to show the work, and that's something we're going to normally do, but for tonight we're going to go through the problems this way. What's the next thing that we would do at this point? Okay, you're going to add 2. So that means then that 2m is going to equal 10. So that's done by an addition. And then to solve the problem, we're going to finish off. We're going to divide both sides by 2, so m equals 5, and that's the division property. Any questions on that? Okay, so here's another example. We have 3x plus 2 times the quantity of x minus 1 equals 8. Okay, so what we're going to do first is we always have to take care of parentheses first. So the first thing that I need to do is I need to distribute. So I have 3x plus 2x minus 2 equals 8. Okay, and that is done by the distributive property. Okay, so you write distribution in. Now, because you have the 3x and plus 2x on the same side, we are going to combine like terms. So we have 5x minus 2 equals 8, and our reason for that is just to combine like terms. It is not an addition because you're not adding this on the other side of our equation. Okay, so since the 3x plus 2x is on the same side, it's just going to be combining like terms. Now we need to get the minus 2 to the other side, so we're going to add. So 5x equals 10, and now you can use the addition property, and then we're going to finish off the problem because you have 5 times x equals 10 by dividing, and that lets x equals 2. So we have division. Okay. All right, any questions on any of that stuff? Okay, at this point, we'll go ahead and pass out the homework for tonight. It'll be worksheet 3.5.